Hey YouTube, just getting set up for this first weld on the long open corner joint, open outside corner. That's the acetylene, oxyacetylene weld I'm going to be doing. It's about 1mm gap or something. This one piece here I've set up, so I'll be testing, doing a little bit of oxyacetylene on that, a little bit of stick, and testing before I actually strike up on the job. It's going to be my first real gas weld for 40 years, so hope all goes well. It won't get in focus. Hey YouTube, there's the finished product. What I'm going to do now is flip the other side for the root penetration. So fully fused. I can't see any of the others achieving that. The camera woman, she was right on my shoulder, and I was hoping to get a thing called the onion in view. I'll draw a sketch of it, of how you achieve full penetration. So I'll pause this now and then do a sketch. Right, here we go. I'm I'm a better welder than Sketcher. That thing there is called the onion. That's where you burn away both parent materials and fill it with filler wire. In this case, I've used TIG wire, double deoxidized or triple deoxidized wire. The best one is copper coated mild steel, but I haven't got that. So if it's an arc weld, it's called a keyhole because it resembles a key. So that one resembles an onion. So there it is. Number 3 nozzle, 2mm thick material, equal pressure process, and the next one will be stick. I'm a bit worried about this one. It's a different animal. It's got an arc force, so I'm going to post this one first, then the manual metal arc, and then hopefully, if I can, when I've done them all one by one, I'll post it all together. That's the oxyacetylene. So it's roughly 60-70 degrees for the nozzle, unless you have to use something else, and 30 degrees for the wire. Perfectly in line. So you'd have the wire fed in, and then vertical to the plate, and the nozzle vertical to the plate. Hope that's of use. Happy welding. Don't forget to subscribe. I've got to 95 so far. This is the warm-up piece that I use to do trial runs before I start that test piece. So I've just finished. So I've just completed the oxyacetylene. So what I'm going to try and do is add this to show you what the onion is that I've vaguely tried to explain. So there's the onion. You melt the two, or burn away the two edges of the parent material. You add the filler wire into a molten pool, and it creates one piece. That there was a pop and bang. You could call it it's a sort of backfire. It proves that there was an imbalance in pressures at the regulators, which I've readjusted. But that is a molten pool that sparked back. And you have to be careful that doesn't end up down your neck or your shoe or on someone else. So that's a sign of imbalance of flow rates to the nozzle. So there's the onion. And if that was manual metal art, which I'm attempting shortly, that would be called the keyhole. I hope this is of use.